So in this problem, a bilayer polymer slab 1.2 meter long, 1.4 meter wide, 5 centimeter thick is plated on a hot plate which keeps the slide of the slab touching the hot plate at 105 degrees Celsius. The thermal conductivity of layer 1, 2 centimeter thick is 0.44 watts per meter times Kelvin, and the thermal conductivity of layer 2, 3 cm thick is 0.67 watts per meter Kelvin. If the air surrounding the slab is 27 degrees Celsius and the convective heat transfer coefficient between the top of the slab and the air is 20 watts per square meter times Kelvin, what is the rate of heat transfer from the side of the slab touching the hot plate to the air? So this is the figure for this problem. This is the slab and this is the hot plate. And this arrow pertains for the direction. So in this problem, we will use this formula since we have to find for the rate of heat transfer. So U here is the overall heat transfer coefficient multiplied by the area multiplied by the temperature difference. So we have to find for U first, since U or the overall heat transfer coefficient is not given. So the formula for U becomes this: 1 over U multiplied by A is equal to 1 over H multiplied by A plus delta X sub 1 over K sub 1 multiplied by A plus delta X sub 2 all over K sub 2 multiplied by A. So plug in the values. We have the value for H of 20. So area here will be cancelled. Now we have to plug in the value. We have for the H of 20. Then for X sub 1, we have 0.02. This pertains for the thickness, and K is the thermal conductivity. So thermal conductivity of layer 1, 0.44 plus the thickness of layer 2, which is 3 cm, convert into meter, we have 0.03 meter over the thermal conductivity of the layer 2, which is 0.67. So plugging it in our calculator, we get 0.140 meter squared or square meter multiplied by Kelvin all over watts. So we have to divide it by 1 to get the value for U. So 1 over 0.140, the answer is 7.13 watts per square meter times Kelvin. So now, since we have the value for U, we can now solve for the heat or the rate of heat transfer. So U, we have the U of 7.13, the area, which is the length times width, 1.2 meter multiplied by its width of 1.4 meter. Then the temperature difference, we have temperature at state 1 of 105 degrees Celsius minus the temperature at state 2, which is 27 degrees Celsius. So plugging it again in our calculator, we get 934.5 watts.